Hi everyone, today we're going to take a look at Festo FluidSIM, a powerful simulation tool for designing and testing pneumatic and electrical systems. Whether you're a student, an engineer, or just curious about how these systems work, this video is for you. In this video, we'll cover the basics of FluidSIM, walk through its interface, and build a simple pneumatic system together. Let's get started. Before we jump into FluidSIM, let's quickly discuss the key components of a pneumatic system, as understanding these will be helpful when we start drawing a pneumatic circuit. A basic pneumatic system is made up of a few key components. 1. Supply elements. These include compressors and reservoirs that produce and store compressed air, and service units that condition it for use. 2. Input elements. Devices like push-button valves or proximity switches that send initial signals. 3. Processing elements, components like directional control valves that direct the airflow. 4. Control elements, the directional control valves that finalize the flow control. 5. Power components, cylinders or motors that convert compressed air into mechanical movement to perform work. Got it? Great. Now let's dive into FluidSIM and see how we can put this knowledge to use. First, let's open FluidSIM. It might take a few seconds to load. Once it's open, you'll notice a clean interface. On the left-hand side, you have the component library organized in a hierarchical view. It includes pneumatic, hydraulic, electrical, and digital components. At the top of the screen, you'll find the toolbar with tools for designing, simulating, and analyzing circuit diagrams. Let's take a quick tour of the toolbar. It's divided into 10 groups. First group contains the tools needed to creating a new circuit diagram, open a save document, and save a document. Second group contains the tools needed to previewing a circuit diagram and print a circuit diagram. Third group contains the tools needed to undo, cut, copy, paste, which will help you to edit circuit diagrams. Fourth group contains the align tool. Fifth group contains the tools needed to rotate and mirror components. Sixth group contains the grid tool. Seventh group contains the tools to zoom in and zoom out. Eighth group contains superficial circuit checking tool, which is used to check the circuit diagram to see if there are any graphic drawing mistakes present. Ninth group contains the basic tools needed to simulate the circuit diagram, such as stop, play, pause. 10th group contains the additional tools needed to simulate the circuit diagram. To get familiar with the interface, let's do a pneumatic question. A single acting cylinder of 25 mm diameter is to clamp a component when a push button is pressed. As long as the push button is activated, the cylinder is to remain in the clamped position. If the push button is released, the clamp is to retract. For this question, we will need 3 components: a compressor, our supply element, a 3x2-way push button valve, our processing and input element, a single acting cylinder, our power component. Now, knowing all the components needed for our question, let's jump into FluidSIM and start drawing a pneumatic system for the above question. First, let's start by creating a new drawing area. Click on New or under File, click New to open a new drawing area. Now, from the Component Library under Supply Element tab, drag Compressed Air Supply Component to the drawing area. This compressed air supply component will supply pressurized air for our pneumatic system. If you want to change the pressure or flow rate of the compressor, double-click on it. Since there are no specific values for pressure or flow rate mentioned in this question, I will leave them as they are. Now let's bring our valve to the drawing area. Go to the Component Library under Valves tab, drag 3x2-way valve. Double-click on the valve component or right-click and select Properties to open the valve configuration window. Before configuring the valve, let's briefly discuss how valve symbols work and how they're named. In any pneumatic system, valves play a critical role. They control the flow of compressed air by opening, closing, or directing it to different parts of the system. This allows for precise operation of actuators like cylinders, ensuring smooth and efficient performance. Now let's break down how these valves are represented in FluidSIM. First, valve switching positions are represented by squares. The number of squares tells us how many switching positions the valve has. Next, let's look at the flow paths. These are indicated by lines, while arrows show the direction of flow. For shutoff positions, you'll notice lines drawn at right angles within the squares. The connections, including inlet and outlet ports, are represented by lines outside the box. Now here's something critical to understand. The directional control valve is named based on three key factors: the number of controlled connections, the number of positions, the initial flow path. Let's look at some examples to clarify this further. This is a 2x2-way valve. The first digit of its name indicates the number of ports, while the second digit tells us the number of positions. Likewise, we can call this example a 3x2-way valve, because it has 3 ports and 2 positions, so we call it a 3x2-way valve. Let's take another example. Here's another valve with 3 ports and 2 positions. Again, we can call it a 3x2-way valve. But how do we distinguish between these two 3x2-way valves? By adding the initial flow path. The first one can be called a 3x2-way directional control valve, normally closed, since in its normal state, air pressure does not pass from port 1 to port 2. The second one can be called a 3x2-way directional control valve, normally open, because in its normal state, air pressure flows from port 1 to port 2. For more about directional control valve schematics, watch this video. These distinctions are crucial when designing pneumatic circuits, as the behavior of the system depends on the type of valve used. Now let's jump back to Festo FluidSIM to configure our valve. Under the valve body, you can add positions, change what they're due, and select the initial position. For this task, we need 2 positions, one that passes air pressure from 1 to 2, and another that passes air pressure from 2 to 3. Furthermore, the initial position should allow air pressure to pass from 2 to 3, as we want the single-acting cylinder to operate when the push button is pressed. Now we need to choose our left and right actuation methods. For both sides, the actuation modes of the valve can be defined individually. These modes can belong to one or more of the following categories: manually, mechanically, or hydraulically, electrically. Additionally, attributes such as spring returned, piloted can be set. An operation mode is selected by clicking the down arrow on the right-hand side of the list and choosing a symbol, or by ticking the appropriate boxes. Below are the names of the symbols for the methods of actuation. If no operation mode is desired for a particular category, simply choose the blank symbol from the list. For this task, we need the left actuation method to be a push button and the right actuation method to be spring returned. Once selected, press OK. Now let's drag our last component, the single-acting cylinder. From the component library under the Actuators tab, drag the single-acting cylinder component to the drawing area. Next, let's change the piston diameter to 25 mm. Double-click on the single-acting cylinder component, or right-click and select Properties. The configuration window for the cylinder will open. In the configuration window, you can modify the properties of the single-acting cylinder. To change the piston diameter, navigate to the Parameters tab and enter 25 mm in the field for piston diameter. If you want to view the velocity and force of the piston, please tick the corresponding boxes and press OK. Now that all the components have been brought into the drawing area, we can start connecting them. First, let's try to connect the single-acting cylinder with the 3x2 valve's port number 2. Move the mouse cursor over the left cylinder port. In edit mode, the mouse cursor changes to a crosswires pointer when it is above a component port. Press and hold the left mouse button while the mouse cursor is above the cylinder connection. Move the mouse cursor with the left mouse button pressed to the 3x2 valve's port number 2. Once the arrows point inwards, release the mouse button. Immediately, a line appears between the 2 chosen connections. To remove a connection between 2 components, left-click the line and press the Delete key. Now let me connect it back. Now let's connect the compressor with the 3x2 valve's port number 1. Move the mouse cursor over the compressor's port. Press and hold the left mouse button while moving to the 3x2 valve's port number 1 and release it. Now we just need to add a muffler to the 3x2 valve's port number 3. To add the muffler, double-click on the 3x2 valve's port number 3. The pneumatic connection window will appear. Click the terminal drop-down arrow and select the muffler. If you want to see pressure and flow, check the boxes and press OK. Now our pneumatic circuit is drawn. Let's check for errors using the Superficial Circuit Checking tool. Click on Check Superficial or press F6 on your keyboard. OK, there are no errors in my drawing, so I can simulate the pneumatic circuit now. Press OK. To simulate, Press the play button or press the F9 button on your keyboard. Now it has started the simulation. The dark blue lines show the pressurized lines and the light blue lines show the unpressurized lines. Let's click the push button and see how the single acting cylinder reacts. To press the push button, bring the mouse to the push button and click on it. If you want to press and hold the push button, press and hold the left mouse button. Our pneumatic circuit works as the question wants. If you want to see the simulation in slow motion, navigate to Options, then Simulation. On the Simulation Speed window, choose Slow Motion Factor and put the ratio 150. Then press OK. Now, by pressing the push button, you can see how the cylinder's speed, pressure, and flow rate change. To pause the simulation, press the pause button, and to stop the simulation, press the stop button or F5 on the keyboard. Please note that you can't edit the circuit while the simulation is running. Thank you all for watching. I hope this tutorial helped you understand the basics of Festo FluidSIM and how to create a simple pneumatic circuit. If you found this video helpful, don't forget to like and subscribe to support the channel. If you have any questions or need tutorials on Festo FluidSIM or SolidWorks, feel free to drop a comment below. I'd love to hear your suggestions. See you in the next video.